Hi, welcome to Chapter 13 of Absolute Java on interfaces and inner classes. This is the first of a 4-video series on Chapter 13. In this video, we're going to talk about interfaces, but we're only going to focus on one of two aspects of interfaces, and that is the ability for interfaces to have method headings. In Video 2, we'll look at the most popular use of interfaces, and that is the Java-Lang comparable interface. In Video 3, we'll come back to interfaces and talk about constants, because interfaces can have not only method headings, but they can also have constants. And in Video 4, we'll look at inner classes. Now, an interface is something like an extreme case of an abstract class. Back in Chapter 8, on pages 500 to 506, we said that an abstract class is a class that has some methods without definitions. The key word was some. Now, an interface is going to have all of its methods without definitions. Now, an interface is not a class, but it is a type that can be satisfied by any class that implements the interface. This is huge, and we'll spend a lot of time with that. The syntax for defining an interface is similar to that of defining a class, except the word interface is used in place of class. So before we might start off with defining a student class as public class student. If we were defining a student interface, it would be public interface student. An interface specifies a set of methods that any class that implements the interface must have. But it contains method headings in constant definitions only. Now, it might just be method headings. It may just be constant definitions, but it can also be a combination of the two. But it contains no instance variables. I'll say that again. It contains no instance variables nor any complete method definitions. An interface serves a function similar to a base class, though it is not a base class. Now, some languages, like C++, allow one class to be derived from two or more different classes. And this is called multiple inheritance, and it's not allowed in Java. In Java, we can only extend from one base class and automatically inherit all of its data members in methods. But instead, Java's way of approximating multiple inheritance is through interfaces. We're going to be able to extend only from one base class, but we're going to be able to implement one or more interfaces. Now, an interface in all of its method headings should be declared public. They cannot be given private, protected, or package access. When a class implements an interface, it must make all the methods in the interface public. And because an interface is a type, a method may be written with the parameter of an interface type. And this is very powerful, and we will see how to use this with different sorting algorithms in Video 2. So here's an example of our first interface. We're going to start off with declaring public interface ordered. Note the word interface instead of class. Public interface ordered. And inside the open curly brace and the closing curly brace, we've got method headings. Only method headings. And one method heading was public boolean follows, and it takes an object. We're trying to see if the calling object follows another object. And the other definition, the other method heading was public boolean precedes an object called other. We're trying to see if the calling object precedes other. Now, what does precede and follow mean? It depends on the person implementing this interface. It could be age. One age precedes another age. Could be height. Could be pay. One pay precedes somebody else's pay. Could be GPA. Could be the name in the phone book. Could be cars on a highway. Could be a hiring date. So to implement an interface, a concrete class must do two things. It must include the phrase implements interface, whatever interface that is, like implements ordered, at the start of the class definition. If more than one interface is implemented, we're just going to separate them with commas. So implements interface 1, comma, interface 2, comma, interface 3. The class must implement all the method headings listed in the definition of the interface. Here I'm showing some UML, and we've seen a good portion of this UML from Chapter 7 when we discussed employee and hourly employee. So here's our employee class, and it was a well-written class that followed best practices. It had 2 private data members, hire, date, and name. It had 3 constructors. One was a copy constructor, a best practice, and one was a no-arg constructor, another best practice. It overrode the equals method, had getters and setters for the data members, and it overrode the toString method. Now, hourly employee, it has a solid line with the open triangle top pointing towards its parent. That's the UML to say that hourly employee extends an employee and inherits all of its data members and methods. An hourly employee added 2 additional data members, one for the number of hours worked and one for the amount paid per hour. Once again, it followed best practices with the copy constructor and the no-arg constructor. It overrode the equals method, had getters and setters for the data members, and overrode the toString method. And now we're going to show that ordered hourly employee extends hourly employee by having a solid line with an open triangle pointing from ordered hourly employee to its parent hourly employee. But we're also going to see ordered hourly employee implementing ordered. So here we're going to have, with UML, a dash line pointing to an open triangle where the child, ordered hourly employee, has the line pointing towards its parent, ordered. And note how an interface has in Gil-Maze the word interface. So in UML, we have the top box with the Gil-Maze interface, the name of the interface, in this case no data members, and 2 methods. And ordered hourly employee is going to provide the full method definitions for those 2 methods. So here's the ordered hourly employee. Public class, ordered hourly employee. We're extending hourly employee. We always put the base class that we're extending first, and then we follow it with 0 or more interfaces. So in this case, implements the interface ordered. We have a no-arg constructor, and then we provide the bodies to the 2 method headings from the ordered interface, one for follows and the other for proceeds. And I show the proceeds body here in pink. And it's pretty simple. If the other parameter is null, we're going to return false. If the other parameter is not an instance of ordered hourly employee, we're going to return false. Otherwise, we're going to cast other into a temporary variable, other ordered hourly employee, and we're going to compare the calling object's pay against the other ordered hourly employee's pay and say that it returns true if the calling object's pay is less. So here I'm trying to show the importance of types and inheritance and polymorphism. If we are an instance of a class, we can be put into a variable of a type of anybody that's in our ancestry, whether that be an interface type or a class type. So I can declare a variable O1 of type ordered, and into that variable I can put in an instance of ordered hourly employee, because an ordered hourly employee implements the ordered interface. This is kind of like I could have put in an instance of a new hourly employee into one of its ancestors, in this case, an instance, a variable E1 of type employee. I could put an instance of a new ordered hourly employee into E2, which was an instance of hourly employee, since that's an ancestor. So it behaves the same way. Now, if we have a class and we're implementing an interface, and if we do not give the bodies to all of the method headings in the interface, those that we do not give the bodies to, we are going to have to call those methods abstract. And if we call a method abstract, we're then going to have to make the class abstract. Okay, so any method headings given in the interface that are not given definitions are made into abstract methods, right? And anytime you have an abstract method, the class has to be abstract. Now, if we have a concrete class, that means we're going to give definitions for all of the method headings given in the interface or given in the abstract class that we're extending. So let's take a look at an abstract class. Let's say we also wanted to grade a safety test, an annual safety test given to all employees. So we're going to create a class, and here we're going to call it my abstract class. And we're going to have the actual numerical grade that we store into a data member called number. And we're going to give that a letter grade that we're going to store into a data member called grade. And for whatever reason, I can write the full body and give the full definition for the proceeds method, but I don't know how to write the follows method. I want to leave that open for somebody that extends my abstract class. So in this case, I would start off with public abstract modifier class my abstract class implements ordered. And here I gave the full body to proceeds, but I did not know how to write the follows, so I did not give it a method body. Because I'm not giving it a method body, I had to put the modifier abstract here. And once I have an abstract method, my class has to be abstract. Derived interfaces. Now, like classes, an interface can be derived from another interface. This is called extending the interface. And to do this, we're going to use the word extends. So the derived interface must include the phrase extends in the interface that you're extending. In a concrete class that implements a derived interface, it must have definitions for any methods, not only in the derived interface, but also of any methods in the base interface. Let's see an example. We have our ordered interface. Now I'm going to create another interface called showably ordered. And I'm going to extend the ordered interface. That means I'm going to get the two method headings in ordered of follows and proceeds, plus the one that I've defined here, show one who proceeds. In any class that implements me, showably ordered, is going to have to provide the full method definitions for show one who proceeds, proceeds, and follows. So to extend an interface, I just use the word extends. Public interface showably ordered extends the interface I'm extending, and then I list only the new method headings that I'm providing. I'll automatically inherit those other two from ordered. Okay, upcoming videos. Next video we'll look at Java-Lang comparable. We'll follow that by talking about constants in an interface and then inner classes. Have a great day.